JDK API libraries and tools in JavaFX. Now we are focusing on JDK API libraries and tools. JDK API libraries and tools. Here you can see conceptual diagram illustrating the components of Oracle's Java SC products. Here we are considering edition Java Platform Standard Edition 8. Oracle has two products that implement Java Platform Standard edition, Java SC8, Java SC Development Kit, JDK, and Java SC Runtime Environment, JRE8. JDK 8 is a superset of JRE8, contains everything that is in JRE8 plus tools such as compilers and debuggers, necessary for developing applets and applications. JRE8 provides the libraries, the Java virtual machine, JVM and other components to run applets and application written in Java programming language. Note that the JRE includes components not required by the Java SC specification, including both standard and non-standard Java components. The Java conceptual diagram categorizes Java component technologies in levels. The technologies that are part of a lower level serves as the foundation for those that are part of higher level. Java language, tools and APIs, deployment and user interface toolkits, integration libraries, other base libraries, lang and util base libraries, Java virtual machine. JDK consists of all levels. JRE consists of the following level: deployment, user interface toolkit, integration libraries, other base libraries, and lang and util base libraries. Java SC API consists of following levels: deployment, no sorry not deployment is not included, user interface toolkits except JavaFX, integration libraries, other base libraries, and lang and util base libraries. Compact profiles consist of the following levels: integration libraries, other base libraries, and lang and util base libraries. JDK, Java SC Development Kit. JDK includes the JRE plus command line development tools such as compilers and debuggers that are necessary or useful for developing applets and applications. JRE, Java SC Runtime Environment. The JRE provides the libraries, Java Virtual Machine, and other components necessary for you to run applets and application written in Java programming language. This runtime environment can be redistributed with applications to make them freestanding. Java SC API, Java Platform Standard 8 API specification. Compact profiles. Compact profiles introduced in JDK 8 enable reduced memory footprints for applications that do not require the entire Java platform. The Java C compiler has a dash profile options which allows the application to be compiled using one of the supported profiles. Java language. A Java programming language is a general purpose concurrent, strongly typed, class-based, object-oriented language. It is normally compiled through the bytecode instruction set and binary format defined in the Java Virtual Machine specification. Java JDK tools and utilities. Java launches a Java application. The Java command starts a Java application. It does this by starting a Java runtime environment, JRE, loading the specified class, and calling the class's main method. The method must be declared public and static. It must not return any value, and it must accept a string array as a parameter. Java C, the Java programming language compiler, Java C. The Java programming language compiler, Java C, reads source files written in the Java programming language and compiles them into bytecode class files. Optionally, the compiler can also process annotations found in source and class files using pluggable annotation processing API. The compiler is a command line tool but can also be invoked using Java Compiler API. The compiler accepts source code defined by the Java language specification, JLS, and produces class files defined by the Java Virtual Machine specification, JVMS. Java Doc. The Java Doc is a tool that passes the declarations and documentation commands in a set of source files and produces a set of HTML pages describing the classes, interfaces, constructors, methods, and fields. You can use a Java doclet to customize Java doc output. A doclet is a program written with the doclet API that specifies the content and format of the output to be generated by the tool. You can write a doclet to generate any kind of text file output such as HTML, HGML, XML, RTF, and MIF. Oracle provides a standard document for generating HTML format API documentation. Documents can also be used to perform special tasks not related to producing API documentation. Java Archive, Java Files. Java Archive is a platform independent file format that aggregates many files into one. Multiple Java applets and their request components, .class files, images, and sounds can be bundled in a Java file and subsequently downloaded to a browser in a single HTTP transaction, greatly improving the download speed. The Java format also supports compression, which reduces the file size, further improving the download time. In addition to applets, author can digitally sign individual entries in a Java file to authenticate their origin. It is fully extensible. Java P deassembles one or more class files. Java P command deassembles one or more class files. The output depends on the options used. When no options are used, then the Java P command prints the package, protected and public fields and methods of the classes passed to it. The Java P command prints its output to std out. JDEPS, Java Class Dependency Analyzer. The JDEPS command shows the package level or class level dependencies of class files. The input class can be a path name to a .class file, a directory, or a Java file, or it can be fully qualified class name to analyze all class files. The options determine the output. By default, JDEPS outputs the dependencies to the system out. It can generate the dependencies in .dot language. Scripting Java Web Services tools. Schema generator for Java architecture for XML binding. WSGen tool to generate JAX, WS portable artifacts. WS import tool to generate JAX WS portable artifacts. XJC binding compiler for Java architecture for XML binding. Security. These security tools help you to set security policies on your system and create applications that can work within scope of security policies set at remote sites. Key tool, manage keystrokes and certificates. JAR signer, generate and verify JAR signatures. Policy tool, GUI tool for managing policy files. Monitoring tools. You can use the following tools to monitor JVM performance statistics. The tools described in these sections are unsupported and experimental and should be used with that in mind. They may not be available in future JDK versions. These tools are supported on all platforms except Windows 98 and Windows ME. JPS, experimental JVM process status tool, list instrumental hotspot Java virtual machines on target system. JStat, experimental JVM statistics monitoring tool, attaches to an instrumental hotspot Java virtual machine and collects and logs performance statistics as specified by the command line options. JStatD, experimental JVM JStat daemon launches RMI server application that monitors for the creation and termination of instrumental hotspot Java virtual machines and provide an interface to allow remote monitoring tools to attach to a Java virtual machine running on local system. JConsole, a JMX compliant graphical tool for monitoring a Java virtual machine. It can monitor both local and remote JVMs. It can also monitor and manage an application. Java Visual VM. Java Visual VM is a tool that provides a visual interface for viewing detailed information about Java applications while they are running on a Java virtual machine JVM, and for the troubleshooting and profiling these applications. Various optional tools including Java VM are provided with the Java Development Kit JDK for retrieving different types of data about running JVM software instances. For example, most of the previously standalone tools, JConsole, JStat, JInfo, JStack, and JMap are part of Java Visual VM. Java Visual VM federates these tools to obtain data from the JVM software, then reorganizes and presents the information graphically to enable you to view different data about multiple Java applications uniformly, whether they are running locally or remote machines. Furthermore, developers can extend the Java VM to Java Visual VM to add new functionality by creating and posting plugins to the tool's built-in update center. JMC, JDK Mission Control. JDK Mission Control, JMC, is an advanced set of tools for managing, monitoring, profiling, and troubleshooting Java applications. JMC enables efficient and detailed data analysis for areas such as code performance, memory, and latency without introducing the performance overhead normally associated with profiling and monitoring tools. JFR, Java Flight Recorder, is a tool for collecting, diagnosis, and profiling data about a running Java application. It is integrated into Java Virtual Machine and causes almost no performance overhead, so it can be used even in heavily loaded production environment. The default settings are used both internal testing and customer feedback. Internal testing and customer feedback indicate that performance impact is less than 1%. For some applications, it can be significantly lower. However, for short-running applications, which are not a kind of applications running in the production environments, relative startup and warm-up times can be larger, which might impact the performance by more than 1%. JFR collects data about the JVM as well as the Java application running on it. JPDA, Java Platform Debugger Architecture. The Java Platform Debugger Architecture, JPDA, consists of three interfaces designed for use by debugger in development environment for desktop systems. The Java Virtual Machine Tools interface, JVM TI, defines the services a VM must provide for debugging. Java Debug Via Protocol, JDWP, defines that the format of information and requests transferred between processing being debugged and debugger frontend, which implements Java Debug Interface, JDI. Java Debug Interface defines information and request at the code level. JVM TI, Java Virtual Machine Tool Interface. The JVM tool interface, JVM TI, is a native programming interface for use by tools. It provides both a way to inspect an state and to control execution of applications running in the Java Virtual Machine JVM. JVM TI supports full breadth of tools that need access to JVM state, including but not limited to profiling, debugging, monitoring, thread analysis, and coverage analysis tools. Java IDL and RMI IOP tools. These tools are used when creating applications that use OMG standard IDL and COBA IOP. TNAM ESERV provide access to the naming service. IJ generates .java files that map an OMG IDL interface and enable an application written in the Java programming language to use COBA functionality. ORBD provides support for clients to transparently locate and invoke persistent objects on servers in the COBA environment. Server tool provides ease of use interface for application programmers to register, unregister, start up and shut down a server. Remote method invocation, RMI tools. These tools help to create applications that interact over the web or other networks. RMIC generates stubs and skeleton for remote object. RMI registry, remote object registry service. RMID, RMI activation system daemon. Serial VER returns class serial version UID. JavaDB 10.11 document. JavaDB is a relational database management system that is based on Java programming language. Java deployment tools, utilities for use in conjunction with deployment of Java applications and applets on the web. Java packager perform tasks related to packaging and signing Java and JavaFX applications. Pack 200 transform a Java file into a compressed Pack 200 file using Java gzip compressor. Compressed packed files are highly compressed Java, which can be directly deployed, saving bandwidth and reducing download time. Unpack 200 transform a packed file produced by Pack 200 into Java file. Internationalization tools. This tool helps to create localizable applications. Native to ASCII, convert text to Unicode Latin 1. Web services tools. schema generator for Java architecture for XML binding, VS Gen tools to generate Java WS portable artifacts. Sorry, it's WS Gen. WS import tool to generate WS portable artifacts. XJC binding compiler for Java architecture for XML binding. Here in scripting, following tools can be used to run scripts that interact with the Java platform. JJS runs the nashorn command line script shell. JRun script experimental script shell for Java runs a script. This tool is unsupported and experimental in nature and should be used within that in mind. It might not be available in future JDK versions. Troubleshooting tools. The following tools can be used for specified troubleshooting tasks. The tools described in this section are unsupported and experimental in nature and should be used with that in mind. They may not be available in future JDK versions. Some of these tools are not currently available on Windows. JInfo, experimental configuration info for Java, prints configuration information for a given process or core file or a remote debug server. JHat, experimental heap dump browser, start a web server on the heap dump file, for example produced by jmap dump, allowing the heap to be browsed. JMap, experimental memory map for Java, prints shared object memory maps or heap memory details of a given process, core file or remote debug server. JSA debug D, experimental serviceability agent debug daemon for Java, attaches a process or core file that act as a debug server. JStack, experimental stack trace for Java, prints a stack trace of threads for given process or core file or remote debug server. Deployment. Have an application ready to publish. Follow these steps for basic deployment. Step 1, decide how you want users to access and run your application. Step 2, create the application package. Step 3, set up the web page, or if your application is embedded in a web page or is launched from the browser. Step 4, copy the package to the location from which you want users to access it. Java Web Start. Java Web Start is an application deployment technology that gives you the power to launch full-featured applications with a single click from your web browser. You can now download and launch applications such as complete spreadsheet program or internet chat client without going through complicated installation procedures. Java applet and Java plugin. Java plugin technology, hereafter the Java plugin, which is included in the Java runtime environment JRE, enables Java applets to run in web browsers on desktop. Java plugin provides powerful capabilities to applets in the web browser while improving overall reliability and functionality of applets in a backward compatible manner. User interface libraries. Swing implements a set of components for building graphical user interfaces, GUIs, and adding rich graphics functionality and interactivity to Java applications. Swing components are implemented entirely in the Java programming language. The pluggable look and feel lets you to create GUIs that can either look the same across platforms or can assume the look and feel of the current OS platform, such as Microsoft Windows, Solaris, or Linux. Java 2D graphics and imaging. Java 2D API is a set of classes for advanced 2D graphics and imaging. It encompasses line art, text, and images in a single comprehensive model. The API provides extensive support for image composing and alpha channel images, a set of classes to provide accurate color space definition and conversion, and a rich set of display-oriented imaging operations. These classes are provided as additions to the java.awt and java.awt.image packages. Abstract Window Toolkit AWT. The Abstract Window Toolkit supports graphical user interface GUI programming. AWT features include a set of native user interface components, a robust event handling model, graphics and imaging tools, including shape, color, and font classes, layout managers for flexible window layouts that do not depend on a particular window size or screen resolution, data transfer classes for cut and paste through the native platform clipboard. Accessibility, Java accessibility guide. The enabling accessibility. If you have a Java application that was designed for use the Microsoft Windows assistive technology and program and Java Accessibility API, JAAPI program. With the Java Accessibility API, developers can easily create Java applications that are accessible to persons with disabilities. Drag and drop. Drag and drops enables data transfer across Java programming language and native applications, between Java programming language applications and within single Java programming language applications. The Java Input Method Framework IMF technology. The input method framework enables the collaboration between text editing components and input method for entering text. Input methods are software components that let the user enter text in ways other than simple typing on a keyboard. They are commonly used to enter Japanese, Chinese, or Korean languages using thousands of different characters on keyboards with far fewer keys. However, the framework also support input methods for other languages and the use entirely of different input mechanisms such as handwriting or speech recognition. Java Image I/O technology. Java Image I/O API developed through JSR 015 provides a pluggable architecture for working with images stored in files and accessed across the network. It offers substantially more flexibility and power than the previous APIs for loading and saving images. The API provides a framework for the addition of format-specific plugins. Plugins for several common formats are included with Java Image I/O, but third parties can use this API to create their own plugins to handle special formats. Java Print Service. The Java Print Service API allows printing on all Java platforms, including requiring a small footprint such as a Java ME profile, but also support the java.awt.print.printjob API. The Java Print Service API includes an extensible print attribute set based on the standard attributes specified in the internal printing protocol IPP 1.1 from the IETF. With the attributes, client and server applications can discover and select printers that have the capabilities specified by attributes, in addition to the included stream print service, which allows applications to transcode data to different formats. Third parties can dynamically install their own print services through the service provider interface. Java Sound Technology. The Java platform includes powerful API for capturing, processing, and playing back audio and MIDI, musical instrument digital interface data. This API is supported by an efficient sound engine which guarantees high quality audio mixing and MIDI synthesis capabilities for the platform. Integration libraries. IDL Java IDL technology adds COBA common object request broker architecture capability to the Java platform, providing standard based interoperability and connectivity. Java IDL enables distributed web enabled Java application to transparently invoke operations on remote network services using the industry standard IDL object management group interface definition language and IIOP Internet Inter-ORB protocol defined by the object management group. Runtime components includes a Java ORB for distributed computing using IIOP communication. Java JDBC API. The Java database connectivity JDBC API provides universal data access from Java programming language. Using the JDBC API, you can access virtually any data source from relational databases to spreadsheet and flat files. JDBC technology also provides the common base on which tools and alternative interfaces can be built. Java naming and directory interface JNDI. The Java naming and directory interface JNDI provides naming and directory functionality to applications written in Java programming language. It is designed to be independent of any specific naming or directory service implementation. Thus, a variety of services, new, emerging, and already deployed ones, can be accessed in a common way. RMI Java Remote Method Invocation API Java RMI. Java Remote Method Invocation Java RMI enables the programmer to create distributed Java technology based applications in which the methods of remote Java objects can be invoked from other Java virtual machines, possibly on different hosts. RMI uses object serialization to marshal and unmarshal parameters and does not truncate types, supporting true object-oriented polymorphism. Java RMI over IIOP. Java Remote Method Invocation over Internet Inter-ORB Protocol Technology RMI IIOP is a part of Java Platform Standard Edition Java SC. RMI programming model enables the programming of COBA servers and applications via RMI API. You can choose to work completely within the Java programming language using Java Remote Method Protocol JRMP as the transport, or work with other COBA compliant programming languages using Internet or Inter-ORB protocol IIOP. Scripting for Java platform. Many implementations of scripting and dynamically typed languages generate Java bytecode so that programs can be run on the Java platform, just as are actual Java programs. Implementing a language in this way, or as a Java interpreter class for scripting language, provides all the advantages of Java platform. Scripting implementations can take advantage of the Java platform's binary portability, security, and high performance bytecode execution. Other base libraries. Java Beans Component API. The Java Beans Component API extends the Java platform write once, run anywhere capability to reusable components development. In fact, the Java Beans architecture takes interoperability a major step forward. Your code can run on every OS and also within any application environment. A developer can create component based on the Java Beans architecture. Beans secure a future in emerging network software market without losing customers that use proprietary platforms, because Beans interoperate with ActiveX, OpenDoc, and Live Connect. Long-term persistence for Beans, Java Beans enables you to read and write Beans as a textual representation of its property values. Security. Java security technology include a large set of APIs, tools, and implementations of commonly used security algorithms, mechanisms, and protocols. Java security APIs span a wide range of areas, including cryptography, public key infrastructure, secure communication, authentication, and access control. Java security technology provides the developer with a comprehensive security framework for writing applications, and also provide the user or administrator with a set of tools to securely manage applications. Java object serialization. Object serialization supports the encoding of objects and objects reachable from them into a stream of bytes. Serialization also supports the complementary reconstruction of the object graph from a stream. Serialization is used for lightweight persistence for communication via sockets, so Java Remote Method Invocation, Java RMI. The default encoding of objects protect private and transit data and supports evolution of classes. A class may implement its own external encoding and is then solely responsible for the external format. Extension mechanism for support of optional packages. This feature has been deprecated and will be removed in future release. Optional packages are packages of classes and any associated native code that application developer can use to extend the functionality of the core platform. The extension mechanism allows the Java Virtual Machine VM to use classes of optional extension in much the same way as the VM uses classes in the Java platform. The extension mechanism also provides a way to wait for needed optional packages to be retrieved from specified URLs when they are not already installed in the JDK or JRE. Java Management Extensions, JMX. The Java Management Extensions, JMX API is a standard API for management and monitoring of resources such as applications, devices, services, and Java Virtual Machine. The JMX technology was originally developed through the Java Community Process (JCP) as Java Specification Request (JSR3), Java Management Extensions, and JSR 160 JMX Remote API. XML in Java SC. XML extensible markup language is a flexible way to create common platform formats to and share both the format and the data on the World Wide Web, intranets, and elsewhere. XML can be used by any individual or group of individuals or companies that wants to share information in a consistent way. Networking, Java networking, Java.NET package, JavaX.NET package, JavaX.NET SSL package, com.sun.net.http server package, com.sun.net.http server.spi package, JDK.NET package. Java endorse standards override mechanism. This feature will be is deprecated and will be removed in future release. For time to time, it is necessary to update the Java platform in order to incorporate newer versions of standard that are created outside of the Java community process, endorse standard, and or in order to update the version of a technology included in the platform correspond to a later standalone version of the technology. The endorse standards override mechanism provides a means whereby the later versions of classes and interfaces that implement endorse standard or standalone technologies may be incorporated into the Java platform. Java Native Interface. Java Native Interface JNI is a standard programming interface for writing Java native methods and embedding Java Virtual Machine into native applications. The primary goal is binary capability of native method libraries across all Java Virtual Machine implementations on a given platform. Java date and time packages. The datetime APIs introduced in JDK 8 are a set of packages that model the most important aspect of Java of date and time. The core classes in the Java.time package use the calendar system defined in ISO 8601 based on the Gregorian calendar system as a default calendar. Other non-ISO calendar systems can be represented using java.time.chrono package, and several predefined chronologies such as Hiraj and Thai Buddhist are provided. Java IO, NIO, and NIO.2. Java IO support is included in the Java IO and Java NIO packages. Together, these packages include following features input and output through data streams, serialization and file system, chassis, decoders, encoders for translating between bytes and Unicode characters, access to file attributes and file systems, APIs for binding scalable servers using asynchronous or multiplex non-blocking I/O. Java internationalization support. Internationalization is the process of designing an application so that it can be adapted to various languages and regions without engineering changes. Sometimes the term internationalization is abbreviated as I18N because there are 18 letters between the first I and the last N. Lang and util packages provides the fundamental object and classes, wrapper classes for primitive types, and a basic math class, and more. Core Java Math. The math functionality includes the floating point libraries java.lang.math and java.lang.strictmath and arbitrary position math java.math package. The collections framework. The collections framework is a unified architecture for representing and manipulating collections, enabling them to be manipulated independently of details of their representation. It reduces programming effort while increasing performance. It enables interoperability among unrelated APIs, reduces effort in designing and learning new APIs, and fosters software reuse. The framework is based on more than a dozen collection interfaces. It includes implementation of these interfaces and algorithms to manipulate them. Package java.lang.ref provide reference object classes which support a limited degree of interaction with garbage collector. Regular expressions. Package java.util.regex classes for matching character sequences against patterns specified by regular expressions. Java logging technology. The Java logging API is introduced in package java.util.logging facilitates software servicing and maintenance at customer sites by producing log reports suitable for analysis by the end users, system administrators, field service engineers, and software development teams. The logging APIs capture information such as security failures, configuration errors, performance bottlenecks, and or bugs in the applications or platforms. Monitoring and management for Java platform. The Java Platform Standard Edition provides comprehensive monitoring and management support for the platform. Instrumentation. Java.lang.instrument package. Java.lang.instrument package provides a Java programming language API for tools to instrument Java programming language applications, for example, to monitor them or collect performance information. Tools use java.lang.instrument to modify the class file that define the class, generally by inserting into the bytecode of methods additional bytecode which perform instrumentation. Java concurrency utilities. The concurrency utilities package provide powerful extensible framework of high performance thread utilities such as thread pools and blocking queues. This package frees the programmer from the need to craft these utilities by hand in much same manner the collections framework did for data structures. Additionally, these packages provide low-level primitives for advanced concurrent programming. The Java Reflection API. The reflection enables Java code to discover information about the fields, methods, and constructors of load classes and use reflected fields, methods, and constructor to operate on their underlying counterparts within security restrictions. The API accommodates applications that need to access to either the public members of the target object based on its runtime class or the members declared by a given class. It also allows programmers to suppress default reflective access control. The package version versioning. The versioning feature enables package level version control so that applications and applets can identify the runtime version, the version of a specific Java runtime environment's VM and class package. Core Java Preferences API. Applications require preference and configuration data to adapt to the needs of different users and environment. The java.util.prefs package provides a way for applications to store and retrieve the user and system preference and configuration data. The data is stored persistently in an implementation dependent backing store. There are two separate trees of preference nodes, one for user preference and one for system preference. Java Archive, Java files. The Java Archive is a platform independent file format that aggregate many files into one, multiple Java applets, and their request component. Class files, images, and sound can be bundled in a Java file and subsequently loaded to a browser in a single HTTP transaction, greatly improving the download speed. The Java format also supports compression, which reduces the file size, further improving the download time. In addition, the applet author can digitally sign individual entries in a Java file to authenticate their origin. It is fully extensible. The package java.util.zip provide classes for reading and writing standard zip and gzip file format. Also include classes for compressing and decompressing data using the deflate compression algorithm, which is used by the zip and gzip file format. Additionally, there are utility classes for computing the CRC32 and EDLER32 checksums of arbitrary input streams. Java Virtual Machine technology. The JDK provide one or more implementation of Java Virtual Machine. On platform typically use the client applications. The JDK comes with the VM implementation called Java Hotpots Client VM. The client VM is tuned for reducing the startup time and memory footprint. It can be invoked by the client command line option when launching the application. On all platforms, JDK comes with an implementation of a Java virtual machine called Java Hotpots Server VM. The server VM is designed for maximum program execution speed, so it can be invoked by using the -server command line option when launching the application. And you can also see JavaFX here. JavaFX is a set of graphics and media packages that enable developers to define, create, and test and debug and deploy rich client applications that operate consistently across diverse platforms. Here you can see JDK and JRE and compact profiles and Java C API. In Java languages, you can see Java language, tools and API, Java, Java C, Java doc, Java P, JD, EPS, scripting, security monitoring, JConsole, Java VM, JMC, JFAR, JDPA, JPDA, JVM, TI, IDL, RMI, Java DB, deployment, internationalization, web services, troubleshooting, and deployment, Java Web Start, Applet, Java plugin, and JavaFX, user interface toolkits, Swing, Java 2D, AWT, accessibility, drag and drop, input methods, image IO, print service, and sound. Integration libraries, IDL, JDBC, JNDI, RMI, RMI IOP, and scripting. Other base libraries are Beans, security, serialization, extension mechanism, JMX, XML, JAXP, networking, override mechanism, JNI, date and time, input output, internationalization. Java Lang and utils, Java Lang and util based libraries, math collections, reference REF objects, regular expressions, logging, management, instrumentation, concurrency utilities, reflection, versioning, preferences, API, Java ship, Java virtual machine, Java hotspot client, and server VM. Here you can see a scene builder could also implement the view in FXML and scene builder. In this example, the UI is built in code. Scene builder is a design-oriented alternative that can be more productive. To convert this example to FXML, the product of the scene builder, you would build the UI in the tool and annotate the field and methods of the employment request class with at FXML, for example. See the following screenshot for how the demo look like in scene builder here. This is informational only and not part of the working demo. Notice that the right half of the UML diagram in MEVM, it's not shown here, could be changed by switching the view implementation from code to scene builder. A sign of a good design is when alternative presentations can be supported easily. As an example, we can consider java.lang package. Provides classes that are fundamental to the design of the Java programming language. Java, as example 2, we can consider Java C, the programming language compiler Java C. The programming language compiler Java C reads source files written in the Java programming language and compiles them into bytecode class files. Optionally, the Java compiler can also process annotations found in source and class files using pluggable annotation processing API. The compiler is a command line tool but can also be invoked using Java compile API. The compiler accepts source code defined by the Java language specification JLS and produces class files defined by Java virtual machine specification JVMS. Now we are considering FXML and scene builder in MVVM pattern in application structure. Scene builder is a design-oriented alternative that can be more productive. Exception example, class exception. The class exception and its subclasses are a form of throwable that indicates condition that a reasonable application might want to catch. This is in package java.lang.